questions on the packet. Again, make sure your names are on them. What I told you is you had to do the first page and 1 2-column proof. And again, this is the 3-6 packet.
Do number 7.
Number 7.
Number 6 or 7?
Pick me one out here.
7.
7. Number 7 says bookends. The bookends are held up with, the books are held up with bookends in the shape of triangles. Measure of angle 1 is 62 degrees. Find the measure of angle 2. So they give us this picture. I'm sorry, I'm not as good an artist as Gretchen, so I'm not drawing that whole thing. I'm just drawing the angles. That's angle 1, that's angle 2. They tell us angle 1 is 62 degrees. How are we going to find angle 2? Somebody help us out? That's our answer.
Number 6.
What are you going to do on number 6? Look at it. Same thing. Somebody help us out.
That's 47.
47, everybody agree with that? Other questions?
8.
Problem 8. A cattle rancher wants to place 3 feeders in his pasture. He researches feeder locations and determines that the most efficient layout is for the feeders to be placed an equal distance from each other and 100 feet apart. With this information, would he be able to locate all 3 feeders along a straight fence line? So first of all, it's a yes or no question.
No.
No?
No.
Now, can we just put no?
No.
On the test on Monday, if you just put no, probably give you a point, if that's the correct answer. But then the explanation would be a couple of points. How come you can't just put them along, if this is our fence, that's our fence, sorry, again, I'm not much of an artist.
It says they need to be an equal distance apart.
So if I put 1 feeder here, 1 feeder here, 1 feeder here, and make them 100 feet, those aren't equal distance apart?
No.
How come?
Because the last one and the first one and the last one are 200 feet apart instead of 100 feet apart.
Well, these two are 200 feet apart, so that's not going to work, is it?
No.
What would they have to be in?
A triangle.
They'd have to be in a triangle. So no would have to form a triangle. And you might even draw a picture, something like this, just to help your explanation. What do we know about all 3 of these segments?
They're the same length.
And they're all 100
Feet apart.
feet. And that would work, right?
Yeah.
Next question.
Can we do 3 on the 2-column groups? It's like this second page, like
Which number is it?
3. 13. Oh, is it? It's 13.
13?
It's just the line is very long, and so I thought it was like a. But that's not just me, right? It's very long.
Yeah, it is longish. Problem 13. They give us a picture. It looks like this. As soon as I see a picture again that looks like this, I think of, and when you see something like this on the test on Monday, segment, a addition, postulate. This segment plus this segment equals that whole thing. This segment plus this segment equals that whole segment. What's the given information tell us so I don't have to keep looking back?
Segment X, Y is congruent to segment W.
Alright, so right there, XY, that's this segment, right? X to Y,
Yeah.
that's that segment. WU, so mark them the same. They give you any other information?
Yeah.
Segment XZ is congruent to segment Z.
Segment
Or
XZ, XZ, is that what you said?
Yeah.
That's this whole thing is congruent to ZU, ignore that. That's that whole thing, right? So if this whole segment over here on the left is the same as the whole segment over there, this part here is the same as that part, what's that tell us about these two bottom parts? This part and this part, they gotta be the same also. What are we trying to prove?
Segment YZ is congruent to ZW.
That's what we just said, right?
Yeah.
So should we be able to go through and prove it? What's our first column called?
Statements.
Second column?
Statements.
What's our first statement gonna be?
Segment XY is congruent to WU.
WU?
Yeah.
Sure. How do we know that?
It was given.
Don't make these two column proofs any harder than they are. I know they're not any fun, but just gotta do them and try them. Probably once you know that, it looks like, just looking at what they have, they're gonna change it from geometry form into what?
Algebra.
Algebra form. What's it gonna be in algebra form?
They gave us, the reason for.
What's this gonna be in algebra form?
X, Y is equal to W.
And the reason that they gave us, I bet, was definition of
Congruent segment.
congruent segments, and we're gonna change that. Mark out congruent segments and write definition of, what did we say? Congruency, just use that every time. Means the same thing, just no reason to use 3 or 4 different things that all mean the same. Number 3, I'm not even gonna look at what they have, I don't even care what they have. I'm guessing the next thing we're gonna do is we're gonna say, this segment plus this segment equals what? The whole segment. So somebody name this segment for me. So XY plus what?
Y is
YZ
equals XZ.
equals XZ. Do the same thing on the other side. You might want to make sure, let's look right here, because they named this WU. What the proof say, the proof statement? CW. So we want to start here and go this direction. Just making sure we're naming them the same as them.
CW plus WU equals ZU.
CW plus WU
Yeah.
equals ZU.
Yeah.
When we're doing that, this plus this equals the whole thing, what do we use?
Segment addition postulate.
Segment, addition, postulate. Looking at what we have right here. We got X, Y, and WU are the same. X, Y, W are the same. Huh. What could we do there? We could stick something in each other's place, right?
Yeah.
So in place of, let's see here, how would we want to do this? Looks looks like they used substitution twice.
Yeah, they did.
Didn't we forget something already? Ah, you know what? Stupid book. What did we forget up here?
The other one.
The other given. They stuck all the given in as one. Ignorant people. So let's do number, this is gonna be different on your paper than it is here. You can fill it in, you can just fill in the spots as we go, I don't care. What given information did we forget?
Z is congruent to ZU.
XZ is congruent to
ZU.
ZU, segment ZU. How do we know that?
It's given.
That was given. And then probably the next thing that we need to do is change that into what form?
Algebra.
So XZ equals ZU. And what did we do to go from 4 to 5?
Substitution. Or no, definition.
Definition of congruency. Now let's look at what we have. I think this is actually supposed to be number 4 on your paper. If these two are the same, what's it tell us about this part over here and this part over here? They gotta be the same, so xy plus yz has to equal what?
XZ.
If these two are the same,
XZ.
if these two are the same, what's that tell us about these two parts?
They're the same.
So this has to equal this whole thing over here. So what are we gonna write on this other side? ZW plus WU. Now, I would change the way they do this. If you did this different on the test, that would be fine with me. I look back up here. What do I know about those two segments? They're congruent, they're the same, right? When I'm looking at an algebraic equation, it's like a balance, right? If I have an elephant over here and an elephant over here, and I take away this elephant, what do I gotta do on the other side? Take away the other elephant, right? Same idea here. If I know these two are the same, XY and WU, XY and WU, what can I do with those two? Take them away. If I take those away, what am I left with? Y, no, I'm not gonna be able to write it all, I don't think. YZ equals ZW. What did I use there?
Is it substitution?
No, subtract, definition, yeah,
Subtraction
of equality.
property, subtraction property of equality. You subtracted the same thing on both sides. Now, you could have maybe put substitution in there as that reason, depending on the other steps that you did. I'm running out of space down here, I can't write the next one. Number 8.
What's number 6?
Yeah, that's what we just did.
Okay.
Yeah, that should have been 6. Mine's just out of order now because I forgot to stick all given into one thing. Number 8, what'd they do on number 8?
They did, oh,
They switched it from
Algebra to geometry.
algebra to geometry, so what's our reason gonna be? Definition of congruency. Sorry, I should have been paying more attention there. Again, make sure your names are on those. You're gonna turn them in here in a second. Page 203. Questions you wanna see worked on page 203.
2.
Number 2. Number 2, it looks like they're using that picture over there at the side, right? Something like this, 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 that's D. If I write something wrong, somebody please tell me. That's A. Boy, that's ugly, but that's B. That's C. That's angle 2 there. Number 2 says angle EBC. Where's angle EBC at?
EBC. In the middle-ish to the.
So
left.
E, we started E, B. So is it just this angle 2?
No.
Like this whole thing, right? And they tell us that that is 55 degrees. So I'm going to mark that as 55 degrees. And angle EBD, where's EBD at?
Not angle 2, but the angle before it.
Here?
No.
EBD. It's just this little part right here, right?
Yeah.
And it's 20 degrees?
Yeah.
And they want us to find angle 2.
Okay, well,
How are we going to find angle 2, this part right here?
20 minus 55.
Close.
It's
20
20.
plus 55.
55 minus 20.
55 minus 20, right? You just said it backwards.
Yeah.
What is 55 minus 20?
It's
So what's the measure of angle 2? And that's using the angle addition postulate. If this angle's 20 degrees, this angle's 35, what's the whole thing?
55.
55, just add them together. Next question. Hannah, are you in the band or in the choir? I'm gonna laugh at you every time you sing. Make sure you look up at me, all right? I'm gonna stand up.
If you do that, then I'm gonna laugh.
I'm gonna stand up at the beginning so you know where I'm at. And as soon as you start singing, I'm gonna be going. You might not be able to see my face.
That's my student.
Wait, how do you say?
Ew. I
Or
can't
I'll,
wait till
I'll
the
stand up and
video.
I'll yell, "Sing it, Hannah!"
Give Hannah a solo.
No, thank you.
Other questions on 203? Everybody understands everything about angles.
Yeah.
Better do at least one of these. Let's see. Let's look at number 8.
Okay.
Number 8, just because I know what's on the test next week. They give us a picture, it looks like this. I'm not going to completely draw this, so I'm not putting the arrows on the ends and stuff. You guys can figure that out. You're not idiots. We got 5 and 6, 7 and 8. What's the given information tell us? So right here in my picture, I'm going to mark those congruent. Everybody watching, because I guarantee there's a couple of these on the test. Stuff that's just basically sort of same idea. You're going to use the same stuff over and over again. So I know angle 5 is congruent to angle 7. What's something else you can tell me from this picture?
5 and 6 are congruent.
How come 5 and 6 are congruent?
They're vertically.
They're vertical angles. You gotta know that. They're vertical angles. Alright? So how should I mark angle 6? One more. What else can you tell me?
7 and 8 also are congruent.
Because they're what?
Vertically.
They're vertical angles also. So how should I mark 8?
With 1.
Just that one arc in there, right? Well, what's that tell me about 5 and 8? What's it tell me about 6 and 8? How about 6 and 7? They're congruent. I don't have any idea what we're trying to prove here, but I bet it's one of those things. What'd it say to prove?
Angle 5 is congruent to angle 8.
Angle 5 is congruent to angle 8. We know that, don't we? So we should be able to go through and do this. First column, statements. What's our first statement going to be?
Angle 5 is congruent. No, that's what we're proving.
Sorry.
Angle 5 is congruent to angle 7.
How'd we know that?
Good to go.
Do we just stop there, take our 2 points, and be glad that we got something? Now what? What'd you tell me next?
Put that in.
Angle 5 and angle 6 were congruent.
Angle 5 is congruent to
Angle 6.
angle 6. How do we know that?
Because of vertical.
And our reason's gonna be vertical angles are congruent. You're gonna use that reason over and over and over again for the rest of the year.
Angle 7 is congruent to angle 8 because of vertical.
Driving me nuts. Angle 7 is congruent to angle 8. Now, before we do that, before I go on to that next one, because I don't want to lose what we've already done up here. If angle 5 is congruent to angle 7, angle 5 is congruent to angle 6.
7 and 6 are also congruent.
So let's go there first. Just so we don't forget it. Angle 7 has to be congruent to angle 6. What did you use there? When you knew that, hey, this is congruent to that, well, I can take out the 5 right here and stick what in its place.
Is that
Substitution property. Substitution property. Now, and the only reason, what Adam told us was right, but the only reason I wanted to go there first, because now this statement that I just made is going to match up with what he said, and then we'll be able to get to where we're trying to go. And what was that next thing?
Angle 7 to angle 8.
Angle 7 is congruent to angle 8. How do we know that?
because it's vertical angles are congruent.
Vertical angles are congruent. Now, I guess I should probably look. I can't even remember now what, we might have screwed everything up.
We're proving that angle 5 is congruent to angle 8, right?
Congruent to 6.
But 6 and 8 are also congruent.
Just trying to see. I could have been wrong, Adam. I thought we were proving something else. I should read the problem first. You might have been, if we would have stuck this up here, 7. Yeah, we probably didn't even really need this one. Because look at what we have now. We said 5 is congruent to 7. 7 is congruent to 8. What do we now know about?
8 is congruent to
8 is congruent to 5. Is that what we're trying to prove?
5. Yeah.
So we didn't even really need that other step.
And that's
So
substitution.
angle 5 is congruent to angle 8. And again, you could maybe use transitive property there, but it's easier just to put substitution. Substitution property. So yeah, we didn't even really need that other step in there. Because if 5's the same as 7, and 7's the same as 8,
5 and 8 have to be the same.
so 5 and 8 have to be the same. What if I put angle 9 on here? What can you tell me about angle 8 and angle 9?
They are linear.
They're a linear pair, I heard that. What else?
They make a one. They make an
They are
they add up to 180.
They add up to 180. What's the other name?
Supplementary.
They're supplementary to each other, so on and so on. Up here, grab the packet, grab the notes. Just one sheet of notes and then a big long packet that's your review. Start filling in what you need to fill in. Oh yeah, I forgot. Turn in the 3-6 packet, make sure your name's on it, turn it in right up there. Black right riding hood, I didn't see your beautiful face.
No, I actually didn't. Sorry. Well, somebody turn this in.
Make sure you turn in the packet up there, 3-6.
We gotta do this over Thanksgiving break.
We hurry up, we're gonna get a whole bunch of it done to fit right in here.
I vote.
Can we use this on the test? 'Cause that sounds like a real good idea.
What'd you say?
I said we should use this on the test, that sounds like a really good idea.
Exactly 90 questions.
You should have popped
I
in
should
another
have
one.
one.
100 won't hurt.
What?
I didn't want to hear you whine when I put 100 on there, so I made it 99.
I'm sure it's good.
I don't know.
I knew as soon as I made
Triple
it
digits really gets
triple digits, somebody would throw a big fit. Now, everybody likes to complain when I do stuff like this, but see, Sean's just now figuring it out, so he's starting to complain.
Oh, goodness.
Number one, a whole bunch of them's easy.
Is this gonna be like the test? 'Cause
Number two, that was my next point. Sometimes I get lazy and I think, you know what? I'll just make out this big long review and then I'll cut a whole bunch of the review problems out and put them together to make the test. So you probably, I can't say for sure, but you probably have the test in your hands right now.
all 99 questions on
The test will not be 99 questions long.
them.
The bad thing is, you have the test, but you don't know which problems the test actually is.
How many questions will it be? 25?
Somewhere around there.
Great.
Will we get all of this done?
Maybe. I don't know. We're going to talk about it. So, filling in this stuff. We're going to go over this on the notes real quick. And then we're going to try to do, hopefully we'll have about 15, 20 minutes left before anybody starts to leave. And we'll try to work problems out on that review packet together. All right? Inductive reasoning. As soon as you hear inductive reasoning, what should you think of?
Pattern.
Patterns every time. So just looking at patterns, and there's some pattern problems on there. Deductive reasoning uses what?
Rules, facts.
Rules, facts, definitions, theorems, postulates, so on, so on, so on. Has everybody got that filled in? We're going to move quickly, so you got to write quickly. And my first misspelling of the thing, I didn't check this very well, so. Huh? You did not.
Yes, I did.
Conjecture.
It's a statement.
Conjecture is just a statement. When you make a conjecture, they're going to ask you probably for the truth value. Is it true or false? Nothing really hard about conjectures. Don't make that harder than it is. A counterexample. A lot of people have trouble with counterexamples. Remember, a counterexample is a specific example that shows something's not always true. So don't try to explain it. If they ask you for a counterexample, you're not explaining anything. You're just giving a specific example. So if I said all numbers are even,
No. 3.
3, that's all you do. You give me the number 3. That's a counterexample, or 1, or whatever. You give me some example that shows that it's not always true. That's a counterexample. Don't explain it. All numbers are not even. I don't want all that. That's not what a counterexample is. Be able to find and explain patterns. Nothing to write down on that. I'm gonna skip over this a little bit just for the simple reason that I want to try to do a whole bunch of problems off of there. A negation. Remember, a negation makes something sort of the opposite of what it did say. A lot of times that involves putting not in there. This is the symbol for negation. So somebody read this to me.
Not. Oh, not a dog.
Not dog. All right? If I said it is raining outside, what would the negation of that be? It is not raining outside. Don't switch it to sunny or snowing or anything else. That changes everything. Compound statements. We use and or to make compound statements. How are you going to remember that this is a symbol for and?
It looks like an A.
Looks like an A.
That doesn't help us.
Exactly. Notice I'm ignoring Clifton because that didn't help anybody and it probably just confused somebody and now they're going to miss it on the test. And
Thanks, Cliff.
thanks a lot, Clifton. And then a disjunction is or, and it's the V looking thing.
Vor.
Oh, yeah.
Remember, for a conjunction statement to be true, what has to happen? They both have to be true. So you might write something in there. To be true, both must be true. For a conjunction statement to be true, both of them have to be true. Both parts have to be true. So if I wrote something like, right angle 90 degrees, that symbol, vertical angles congruent. You just look at it. Is this part true?
Yeah.
Yeah.
Is this part true?
Yeah.
So what's that tell me about the whole thing?
It's true.
It's true. Right? If I changed it and said right angles are 190 degrees, is that part true?
So then.
What do we know about the whole thing then?
False.
The whole thing is false.
What if it was or?
Now that's what we're getting ready to do next. So if I change this and I put or in there instead of and for a disjunction, what has to be true for the whole thing to be true?
At this time, I need all choir members down to the still band room to get ready, and also band members, thank you.
What has to be true on this one?
Only one of them? One statement?
You guys stop back and see me and we'll talk about the review packet, all right? Test on Monday. Only one, all right? So one must be true
It's a really straight line.
for the whole thing to be true. Whole statement. Sorry, that's really terrible grammar. So if one or the other's true, if it's got the word or in it, one or the other's true, then the whole thing is true. Gretchen, you might say something to her too. My intervention tomorrow might be not a bad idea. Fill in what you need to fill in on this. What's another name for a conditional statement? If and then statement. Who answered that?
Kylie.
I can go home and die a happy man tonight. She listened to me at some point. That's all I wanted. My life is complete. Somebody call Mr. Eiler up. I quit. I'm done. I can't get any better than this.
I got you.
Call him. I can't do any more. Get over there and write and quit messing around. You need to get your grade up. You get on my nerves.
You said call.
I say a lot of things. You never listen any other time. I said to do the homework last class. You're gonna get back on track for me, right, so I'll leave you alone? You promise me. Look me dead in the eye. Look me dead in the eye and promise me.
I will try.
No. Guarantee there's one question on there deals with converse, inverse, contrapositive. Whole bunch of questions that deal with conditional statements, knowing what conditional statements are and everything. Remember, it's an if and then statement. The if part's called the what? Hypothesis. The then part's called the conclusion. What's a converse do to a statement?
It switches the hypothesis.
Inverse
Negates it.
negates both parts. Contrapositive switches and negates. So if I did this, if, this is our original statement, if right angle, then what do you know about it?
It's 90 degrees.
90 degrees. Is that a true statement?
No.
So you probably have to tell that it's true. What would the converse of that be?
If 90 degrees, then right angle.
If 90 degrees, then right angle. Is that true?
Yeah.
Inverse. Be careful with the inverse. What's the inverse going to say?
If it's not 90 degrees.
That's where I want you to be
If
careful.
it's not right
No.
angle, then no.
Always go back to the original, right? Don't make that mistake. These aren't hard. So if not what?
Not right angle,
If not a right angle,
then not 90 degrees.
then not 90 degrees. Sorry if I can't read that. Is that true or false? That's true also. What would the contrapositive be? I'm not even going to write it down because I'm running out of room.
If not 90 degrees, then not right angle.
Switch it around and negate it. So if not 90 degrees, then not a right angle. Sorry, Sean, am I in your way? Well, Sean, why don't you like move over here somewhere? Because I keep forgetting that you're sitting. I try not to sit in my biconditional, statements biconditional. If the original statement and the converse are both true, we can use that sort of word to say this is true if and only if. That means if and only if. If I write something in this form, just says P implies Q, all right? But if I put it this way, it's telling us P is true if and only if Q is also true. So it means it works both ways. Law of detachment and law of syllogism. With the law of detachment, you're going to be given a whole statement. If P, then R. And they tell us that that's true. Then they're going to take the hypothesis all by itself and say P all alone is true. But it has to be the hypothesis. All right? And then from that, what we can conclude is that the conclusion over here all by itself is true. So if I said something like, if dog, then bird, and I told you dog all by itself was true, what can you conclude?
That bird is true.
The bird all by itself is true. All right? Don't make it harder than it is. Law of syllogism says something like this. If dog, then bird, I tell you that's true, and then I say, give you a whole nother statement, and I say, if bird, then Tom. Law of syllogism says, if these two parts are the same, the conclusion of the first statement, the hypothesis of the second statement, if those two are the same, we can take this hypothesis and this conclusion and put them together, and that statement has to be true. Does that make sense? You guys can handle that. I probably make those harder than they actually are. You guys are smart enough that you can. Right, Kylie? Things to make sure you know. I don't think I. Is there anything to fill in on this?
Yeah.
Oh, is there? Oh, there's a lot. Know all postulates and theorems. I just put some examples in there, things that you gotta know. Stuff like segment addition. Segment addition, you're given something that looks like this. You're probably using segment addition. No, all right angles are congruent, no vertical angles are congruent. Be able to pick that out. Remember with vertical angles, it might look something like this. That's angle 1, that's angle 2. Well, those are vertical angles, they have to be congruent. Make sure you know what linear pairs are, know what supplementary, complementary, midpoint. What's a midpoint do? Split the segment into two equal segments, two congruent segments. What's collinear mean?
On the same line.
On the same line. What's this upside down T mean?
Parallel. No. Perpendicular.
Perpendicular, and it means perpendicular, and that tells you what? As soon as you see perpendicular, you should think of what?
Right angles.
90 degrees or right angles. Got to be able to put those things together. Supplementary, what's supplementary mean again?
Supplementary is 180.
They add up, two angles add up to 180. What's complementary?
Add up to 90.
They add up, two angles add up to 90. Can you read that? Is that a no? Can you read that? Yeah. Clifton, is this 3 classes in a row you've been here? We should add a party today.
I'm glad you can make it, but
I think it is, isn't it? And this 3 classes in a row? I just thought about it. Don't give me that look. I don't know, you had that look on your face like you were. Be able to do these proofs. Algebra proofs, 2-column proofs that deal with segments, 2-column proofs that deal with angles. Fill in, I think I just had you fill in these 3 things, didn't I, on each one?
yeah.
Just some important things to remember. If you're dealing with segments, segment addition postulate, midpoint, definition of congruency. Definition of congruency we could have also put down here with this one because it just switching from geometry to algebra or algebra to geometry. And if you're dealing with angles, an angle bisector, what's an angle bisector do?
An angle bisector. Bisects an angle.
Bisects an angle, that doesn't really help me a whole lot when this is
Splits
saying.
an angle into 2 equal angles.
There you go, splits an angle into 2 equal angles. Do you guys do that in English class on your, when they give you vocab? And they ask you what an angle bisector is and you say bisects an angle?
No.
That doesn't work out too well, does it?
I don't think we did vocab.
You don't do vocab anymore?
I don't think so. Can't tell you a lot, maybe fourth grade.
Really?
Yeah.
Maybe that's part of the problem. We need to get back to simpler times a little bit.
I wanna go back to reading Dr. Seuss books.
Stuff like
One fish, two fish, red fish, blue fish.
If you're done writing, get out the packet, start looking through it, figuring out problems that you want to see work. We got about 10 minutes. We'll get as many done as we can in that 10 minutes. If you pick one really, really hard one, we'll probably get one problem done. If you pick a whole bunch of different ones and we can run through them pretty quick and everybody's answering questions, we can probably get a whole bunch done.
that. All right, two.
Are we ready?
Number two.
And I will not go in order. So if you say 2, 3, we're cutting it off. Find other stuff, all right? Because some of them that are all together are basically the same thing. Number 2, to start with. Let P be you are a senior, and let Q be you are in high school. Write a conditional statement. Remember, another name for a conditional statement is what? If and then. So we want to write that as a conditional statement. So I'll give you the first word. If
You are a senior.
you are a senior, I'll give you another word. Then
You are.
you are in high school. Then decide whether it's true or false.
True.
If you are a senior, then you are in high school. True? So is that one of the answers down there?
Yeah, it's C.
C?
Why does the paper look all
I
brown?
spelled what wrong?
Can we do 25?
25.
26. 26.
26?
Yeah.
Doggone, we are skipping.
Yeah, I don't think that's 26.
99.
26 says this, angle EFG is congruent to angle EFG. The directions say, name the property that the statement illustrates.
Isn't that symmetric property of congruence?
Symmetric is when they flip it, right?
Symmetric's when they flip around.
Transitive is like
Transitive
substitution, right?
is like substitution.
So it's reflexive.
What's reflexive property? 3 words.
Reflect. That's on C.
Reflexive.
Reflexive property.
What's the 3 words that go with reflexive property?
Agree.
Boy.
Anything equals
Itself.
itself.
Thank you. That's worrying me that you guys can't remember that. Reflexive property. Anything equals itself. Reflexive property.
25 is B, by the way.
So what's the answer?
Nice. A.
A.
Can we do 69 has 3 parts?
25 is what?
25 is B, I'm pretty sure.
B.
Yeah.
Reflexive property again.
Yeah.
Which one are we doing next?
69 has 3 parts.
Says statement P is true, statement Q is false. So P, we know is true. Q, they use a capital Q, don't they?
Yeah.
True is false. Part A says P, that symbol, Q.
P and Q, which means it's true.
It's true?
Yeah, it's gotta be if they're using and, right?
So it's
No?
false, because they're using A.
Since they're using and,
It is false because.
Both parts have to be what for the whole thing to be true?
True.
Both parts have to be true. Are both these parts true?
No.
So the whole thing is false.
So it can't be and, right?
Well, that is and. It says P and Q. And they're asking you to tell whether it's true or false.
And, okay.
Part B says, well, that's a little messed up. P or Q. So P is true, Q is false.
So it's true.
So this whole thing is true, because if it's or, then only one part has to be true for the whole thing to be true. This one says, somebody read it to me?
Not P, not or.
Not P or not Q. Well, if P was true, then not P has to be what? False. If Q was false, not Q has to be true. We used or again, so what do we know about this whole statement? It's all true, because only one part has to be true when you use or. Next question. 85. Year I graduated.
Here's my mom's phone.
Says, write as an if and then statement. A parallelogram is a quadrilateral with two pairs of parallel sides. I'm going to help you out. Give you the first word.
If parallelogram is quadrilateral,
Send two pairs.
then two pairs. Wait.
You want it to make sort of some kind of English sense, right?
So if
If
a
a
parallelogram is a quadrilateral, then there will be two pairs of parallel sides.
You might want to turn the first part around. If,
If there are two pairs of.
no, don't turn the whole thing around, then we're doing the converse.
If quadrilateral.
So if a quadrilateral is a what? Parallelogram, sorry, I'm going to abbreviate because I'm running out of space over here. Parallelogram, then, I'll give you another word,
Then
what's it have?
two parallel sides.
Then has two pairs, pairs, don't want, clicked into tell me I spelled something wrong again, of parallel sides. I'm just writing cursive all the time, and you'd never know. What's this part called again?
The
Hypothesis. What's this part called? Conclusion. They didn't ask us for all that, they just asked us to write that out.
86.
86.
What?
We're doing the same thing?
If a rectangle is a parallelogram, then it has four right angles.
So, if, and again, we probably want to turn this first part around. If a parallelogram is a rectangle, and I wouldn't mark it wrong if you didn't turn it around, then
You would or wouldn't?
I wouldn't.
Okay.
Then what?
Has four right.
Then has four right angles. This part's called the what again? And this part's called the next one. 80 what? 9? 89. Probably be the last one since it's a two-column proof. I have another slide.
I want to read right.
No. So 89 says, no.
What'd you do?
My pen shut off on me.
It's Mikey's fault. It's Mikey's fault.
89 says, what is that, 2 parentheses 3x
Minus 5.
minus 5
Equals negative four.
equals negative 4. Please, I don't know, I've said it in several of my classes, but not all of them. Anytime if we're doing on any test, if you see something that looks like this, it's not a division sign. Never, ever, ever will I make a division sign that way. It's always a plus sign. All right? So don't ask me, hey, is that division or plus? It's always plus. You'll never see me make a division sign that way on anything. Printers don't like addition signs. And so whenever you print them off, they look like this. But that's always in here. It's always going to be that way. We go to write our 2-column proof for this. And I'm just hurrying through this so we can make sure we can get this one done. What's our first statement going to be?
Two.
Oh, wait, no, that's my bad.
That whole thing, right?
Yeah.
Equals -4. Is that right? How do we know that?
Because there's a given.
Silly.
Now what?
Distribute.
What do we get when we distribute?
6x.
Minus 10 equals -4. Make sure on the algebra stuff you know all these properties. What property did we use?
Distributed property.
Distributive property. Now what?
Negative.
Add 10 to both sides. What's that leave us with?
6.
6x
X
equals
equals
6.
6. X equals 1.
How do we go from 2 to 3?
You.
Addition, property, ignore that, stray mark, of equality. Don't forget to put that of equality on there because we did it to both sides. Now what?
Division property of equality.
That's going to be our reason. What's our statement?
You go to,
It's just X. I mean, it could be just
It's
X.
X.
1.
X equals 1. What's our reason?
Division property of equality.
Division property of equality. We might have time for another one.
How about,
18, not 18.
hang on. Ooh. Can we do 99?
99.
Sorry.
I'm
No, wasn't true.
sorry.
That's fair.
So everybody got this one so I didn't erase it?
Yeah. Oh my. This is.
So on this one, I'm not going to draw all the streets and everything. I'm just going to draw these lines going across through here.
1, 2.
And then you got this line going down through here. That's angle 1, that's angle 2, that's angle 3, that's angle 4. Boy, does this look familiar?
We just
Yeah,
did this.
We just did this problem, or something really, really close to it. What's the given information this time?
Angle 1 is congruent to angle 2.
So let's mark that in our picture there. That's all the given. What else can you tell me?
Angle 1 is.
Angle 1 is congruent to angle 2.
How come those two are congruent?
Because of
The
vertical.
vertical angles are congruent. What else can you tell me?
3 is congruent to 4.
3 is congruent to 4 because they were vertical angles. Well, what's that tell me about all 4 of these? They're all congruent. Let's see, Ebersole's gonna make sure that he looks at what he's trying to prove this time. So 3 is congruent to 2 is where we're trying to get to. What's our first statement gonna be?
Angle 1 is congruent to 4.
Angle 1 is congruent to angle 4. How do we know that?
It's given.
Number 2, what are you gonna say on number 2?
Angle 1.
That wasn't, angle 1 wasn't congruent to angle. Okay, yeah, I've looked at the wrong problem.
Teachers, part of their option in just a couple minutes, we're going to get ready to dismiss the
Angle 1's
high school
congruent to angle
gymnasium
2.
for our Veterans Day Assembly.
How do
Before
we
we
know
do
that?
so, students, I want to remind everybody that we have a number of guests in our building, and my expectation when we have guests in the building is we are our best above the line behavior, and that we are owning all of our actions as a part of that completing the puzzle.
Before we do that, what do
every
we know
day.
about these two?
In addition, students and teachers, I ask that there be no hats or hoods worn during this assembly out of respect for our veterans. So if you have a hat or a hood on, you must take that off before you come down to the assembly. In addition, we are going to be seated on the home side of the bleachers today. which is a little
Now,
bit
what do we
different
know
than we have
about
done
these
in
two?
the past. Seniors, you will be in the next to last section, next to where you normally sit for homecoming. That final section is reserved for our fourth grade and high school choirs, so we need to make sure that they have that space. There will be people down to guide you. Again, teachers, we ask that we also sit amongst our students as well. So with that, I would like to release juniors
So they
and
sit by
seniors
classes?
to the high school gymnasium. Please take off your hats and hoods and walk calmly and respectfully from the gym.
Yeah, you can leave your stuff in here. Once we know that, last step real quick. 4 is congruent to 2 and 3 is congruent to 4. What do you know?
3 is group 2.
3 is congruent to 2.
Mr. Ebersole, can I use the reason?
And our reason there would be substitution property. Picture looks something like this. If I write something wrong, somebody please tell me.
We're on a music note.
Oh. Yeah, it's supposed to be a toe.
Loud.
What's the given say?
NP is segment NP is congruent to segment LP.
So that's this segment is congruent to OP,
LP.
LP. This segment, so mark them congruent. Again, anytime you're doing these 2-column proofs, that's where you should start. Start by marking stuff. Is there other given information?
Segment LN is congruent to the segment MO.
That's given to us?
Yeah. No,
Are you on the right one?
I was reading it wrong.
So that's all the given information?
It is.
And what are we trying to prove?
PN.
PN is equal to PN.
PN is congruent to PO.
It says equal.
Oh, equal, all right, my fault. MP congruent to LP. Notice in number 1, they messed up, or I messed up because I didn't check it. I think there's supposed to be another piece of given information. What was that?
The segment LN is congruent to the segment MO.
Right, so this whole thing is congruent to that whole thing, right? That's supposed to be in the given, they have it in the steps
It
down
is in
there.
the statements, it's.
Right, but it's not in the, they didn't put it up top where they're supposed to, so it must have, I don't know if it got cut off or what. If this whole thing is the same as this whole thing, this part is the same as this part, what can you tell me about these 2 parts? They gotta be the same, right? Again, remember, anytime we're looking at something like this and we're saying this segment and this segment together make this whole thing, what are we using? Segment addition postulate. Now, somebody else said vertical angles. That looks like maybe we do have vertical angles in this picture, right? But this time, are we using them? So sometimes you'll have other stuff in there that we're not really using. So somewhere in our proof, we're gonna say this segment plus this segment equals that whole thing. This segment plus this segment equals that whole thing. And then we're gonna get rid of these 2 parts. And what do we know about the 2 remaining parts? They have to be congruent or the same. Now, I think that's what we're trying to prove, isn't it? What's our first column called again?
Statements,
Second column?
reasons.
What's your first statement gonna be? I think they give it to you, didn't they? Or they told you?
Segment NP is congruent to segment LP.
And they stuck it, and this is what they get for sticking it all in one thing instead of separating it like they should. They forgot to put it in the other part.
Why don't you have this done?
What's the second one?
Segment L and
This is not done.
segment
Why is it done?
ML,
M-O.
MO? How do we know those two
You
things?
just told us this thing was done.
Number two, the reason they give you says definition of congruent segments. It should say this, change the reason to this. Definition of what? Congruency. Change it to that. That's what we want. Instead of changing everything all the time, we want to use just that one thing. If it's definition of congruency, what's that telling us that we're doing to this stuff?
You're changing it to algebraic form.
So what's it gonna say?
MP equals LP. and
MP
LN
equals
MO.
LP and
LN equals MO.
LN equals MO. Did they give you any part of number three?
Yeah.
They gave us, they didn't give us the reason, they gave us the whole statement.
Statement?
Yeah.
What's it say? All right, let's turn it around. What segment up top there do we have? What's that top segment up there?
MP.
MP plus, what's this segment down here? PO equals the whole thing, which is MO. How about going the other way? What segment here?
LP plus PN.
LP plus
PN.
PN equals the whole thing, which is
LN.
good. Anytime you're doing that, this segment plus that segment equals the whole thing, what are we using?
Segment addition.
Segment, addition, postulate. Now, as I'm looking at this, I look right here. Anybody see anything right there?
What do?
What do you see? And why am I thinking that that's something that we could use?
Usually so they give them
What's that say?
Ln is
Do you see any of those anywhere else?
yeah, number one, or not, that, but,
Right there, right?
yeah.
If these two are equal to each other, what do we know about this whole thing on this side and this whole thing on this side?
They're equal to each other.
They gotta be equal to each other. Now, I'm not sure which way they did this one, so I'm not looking at it. But I'm guessing that they said, okay, these two are the same, so in this next step, this has to be the same as that. So MP plus PO has to equal what? LP plus PN. What do we use there? When we know two things are equal and we take one out and stick something else in its place,
Substitution property.
substitution property.
Yep.
Is that the reason they gave us? Did they give us that reason?
They didn't give us that reason.
Oh, they didn't give us a reason on for? They
They
gave
only
the
gave us
statement?
reason to advance. Yeah, I gave the statement.
Oh, I'm looking at the wrong thing. So do I have the right thing, what they have?
Yeah.
I was looking at 13 instead of 12. Basically the same things, aren't they? So once we have that, did they give us a reason for this next part?
No.
They didn't give us a reason? They gave us a statement? I'm guessing that their statement's gonna say something like, if I look right here, what do I know about MP? Equals LP. So anywhere that I see MP, I could stick what in its place? LP. Or anywhere I see LP, I could stick what in its place? MP. I don't know. What's their statement say?
Says LP plus P.
LP plus PO equals, oh, that was supposed to be a P in there, wasn't
Just hit number 5, you're fine.
Yeah.
We know number 5.
Yeah.
Four's right.
4's right. What's 5 say?
LP plus PN.
Equals L.
But, well, you can keep that because then it equals.
They got
LP
it, so
plus
they,
P.
they got it turned around on me?
Yeah.
So LP plus
That would be PN.
PN now, they just got it turned around on us?
Yeah.
My fault. What'd they use there? They took out what? MP and stuck LP in its place, what'd they use? Substitution, property. How many more steps they got? One more? That's good, then they actually did this one the way I would have done it. You got LP over here and you got LP over there. As a matter of fact, I wouldn't even have done this step. That's an extra step, no reason to it. Because if we know LP and MP are the same, what could you have actually done with them? Just did what?
Cross them out.
Got rid of them. They're the same on two sides of the equal sign, just subtract them both off, and we end up with just this. What did they end up with if we get rid of LP on both sides?
PO equals PN.
PO equals PN. What did we do there?
Subtraction property of equality.
Subtraction, please remember this for the test. We do have a test on Monday, did I say that?
No, I don't think.
Test on Monday. Please remember, when you do something to both sides of the equal sign, you gotta put of equality. So subtraction, property of equality. Is that what we were trying to prove?
Yes.
What if we were trying to prove this? PO is congruent to PN.
Definition of congruent segment.
Then we just go back up here and do this, right? Could be definition of congruent segments also, that's the same thing. But definition of congruency is what we've been using. There is no step 7 here, that's just me doing extra. Next question.
Number 1.
Number 1. Number 1, does everybody see the picture over there on the side?
Yeah.
So in your picture over there on the side, trace angle MPN. Trace angle MPN. What do they tell us about angle MPN?
It's 35 degrees.
So write 35 degrees in there, inside that angle, close to the vertex. Then angle 3, they tell us the measure of angle 3 is 90 degrees. Does everybody see angle 3?
Yeah.
Put 90 degrees in there. So write it in where it says the number 3 there.
Number 35.
Number 2 was 35.
We haven't done those yet. We're just doing this right now.
Well, we're on Hayden, we're on number 1. And we got this picture. Sorry, I'm not going to draw it real well. Just doing it here. MPN is this angle, right? So we wrote 35 degrees in there. Mine looks terrible. And they told us angle 3 was how much?
90.
So what am I going to write in here?
4 squared.
90 degrees, or little box. What do you know about all 3 of those angles together?
They equal 180.
They should add up to 180. Somebody get their calculator out and help me.
55.
So Thelma's telling us that 55 is left over for that angle. Anybody else agree with that? So what's the answer to number 1?
55.
55 degrees. 55 degrees. Give me another one. 5? 5 uses the same picture, right?
Yeah.
Switching on. So if I just do this, Brandon, is that going to confuse you?
Yeah. I think you should redraw it.
Yeah. Keep thinking that. It's not going to happen. Angle MPN. Where's angle MPN at? That's his top angle again, isn't it? Is that right? It's 32 degrees, so write 32 in there. Please make sure, Dallas knows, they're using the same picture for different problems, right? Does that mean angle MPN is still 35 degrees like it was before? No, now you're using something else, all right? So don't think that. Angle 3 is 89 degrees. It's the same daggone problem, isn't it? And we're trying to find this angle right here. What are we going to do to find that angle?
Subtract 32 and 89 from 180.
So add these two up. Might be easier to add these two than subtract from 180. Somebody help me out. What's 89 plus 32?
121.
Well, I hope all you guys got your calculators out come Monday when we take this test. Is it a big calculator? Ask me here in a minute while I walk up there and I'll get some better. All right. What'd it come out to be? 121. Anybody else get that? Subtract that from 180. What do you get?
57.
57?
59.
59?
Yeah, I got 59.
Is that right? 59?
Yeah.
I just mistaken 99%.
Nothing wrong with that. Thing that is wrong with it. Get a calculator out and do it on there instead of doing it in your head.
I didn't.
Next question.
What if you type it in?
Then you'll miss it just like you would if you did it in your head.
Gotta weigh your odds.
I'm good.
I'm doing
Hang on to that for a second. You're going to turn it in here in just a minute. But for now, page 203. Looking at page 203. So books open to 203. It's not my book. Somebody else's. They tore this. This goes back to the a while ago. Computer's not always being. Questions on 203? Trying to be positive today, but some of you are going to be really, really unhappy when the interims come out tomorrow.
16.
Problem 16. Problem 16. So everybody got all this? I can erase it. Probably can't read it now anyway. Problem 16 on 203. It's actually on 204. My fault.
Where's this supposed to go?
We have a picture. It looks like this. It's a good problem to bring up because I need to say something about this. Do all four of these angles together make a straight angle?
Yes.
No. If all of them together made a straight angle, they'd all add up to 180, right?
Yeah.
That's not the way this works. How many straight angles do we have in this picture?
2.
There's one there, one there. Even though they're the same straight angle, don't think that they all add up to 180. It doesn't work that way. What they tell us on number 16? So,
2 and 4 and 4 and 5 are supplementary.
did they have to tell? Oh, what they say? 2
They
and.
said 2 and 4, and then 4 and 5 are supplementary, and measure 4 is 105.
Did they have to tell us that 4 and 5 were supplementary? We already knew that from the picture, didn't we? What do we know about 2 and 3? They're supplementary. Now they did tell us that 2 and 4 are supplementary. What's supplementary mean again? They add up to 180. Two angles that add up to 180. I'm sure they told us one of the angles. Which one did they tell us?
4 is 105.
So angle 4 right here is 105 degrees. Can you read that? 105 degrees. Tell me one angle that you can find.
Angle 3.
Easiest one. Angle 5. What do you know about this angle and angle 5? Add up to 180. What's angle 5 then? 75 degrees. They told us 2 and 4 were supplementary. So what's that tell us about angle 2? It's got to be the same thing, doesn't it? 75 degrees. Once we know that, can we now find angle 3?
Yeah.
It's got to be
105.
105 because 2 and 3 have to be supplementary. What did they ask us to find? Angle 4?
No, it says, well, in the instructions above, it says find the measure of each numbered angle and name the theorems that you use to justify it.
Oh, so they wanted all these angles. So we got that, and that one.
Yeah.
What did we use to figure? What did we use to figure out angle 5?
Subtraction.
Don't make it harder than it is. Explain to me, or just tell me, what definition or whatever, what rule did you use to
Linear pair.
find this? I would accept that. Linear pair. What's another word I probably would have accepted there? What do you know about those two angles? Supplementary, so on and so on. Let's see. What rule did we use to find angle 3 here?
Supplementary.
Supplementary linear pair, same thing, wasn't it? Now, one of them we did use this. Angles supplementary to congruent angles are what? Congruent. That was one of the theorems that we wrote down last class. If two angles are supplementary, actually not congruent angles, this would be the same angle because they said they were supplementary both to angle 4, right? If they're supplementary to the same angle, then they have to be congruent. Other questions on 203? Everybody's just ready for this test. We should just take the test today and be done with it.
No.
No.
Can we do number 6?
I'd say
Six.
solid 6%.
Number 6. Watch, Brandon. I'm going to try to do this one the other one. See if it's shorter. Number 6. Give us a picture. So it looks something like that. Is that pretty close?
Yeah.
Somebody tell me the numbers.
1, 2.
1, 2, is that right?
Yeah. And then 4.
4 is the bottom one?
Yeah.
And 3 is the top one?
Yeah.
What do you know about angle 1 and angle 2?
There's
Complementary.
They're complementary. I'm going to write that up here. Angle 1 is complementary to angle 2. What do you know about 3 and 4? Complementary. So I'm going to write that up here. These are just my notes, thinking things through here. We also know if this is a right angle, that's a right angle. They're
all right
congruent to
angles
each.
are-
They're all right angles are congruent. I don't know if that'll help us here or not. Did they give us any given information?
Angle 2 is congruent to angle 4.
So we mark that in our picture. Please make sure you're marking these pictures. Angle 2 is congruent to what?
4.
Angle 4? Well, my picture looks terrible then, doesn't it? It's like everything's backwards.
Does that mean that angle 1 is congruent to angle 2?
And we're trying to prove that angle 1 is congruent to what?
Angle 3.
Angle 3?
I don't really know.
Angle 2 is congruent to angle 4 when you have to do the same subtraction as last time.
So we could go through and say, these two angles added together give you that whole thing, right? These two angles added together give you that whole thing. We know these two parts are the same, so what has to be true about these other two parts?
They have to be the same.
So we could use angle addition postulate. Instead of using that, I'm going to use a different way because me and Brandon did this one together. And I want to do it a different way this time, just to show you a different setup and see if it's a little shorter. First column again is what?
First statement.
Statement. Second column.
Reason.
What's our first statement going to be?
Angle 2 is congruent to angle 4. Given.
That was given.
Yeah.
Now, as soon as we seen this picture, what'd you guys tell me about angle 1 and angle 2?
And angle right angle.
They were complementary. So I'm going to write that next. Angle 1 is complementary to angle 2. How'd you know that those two? Delma sort of told us a second ago.
They make a right angle.
A right angle, like Tom said, right angle.
So
And 90 degrees is
it's sort
constant.
of hard to explain, right? But listen to the way I'm going to tell you so that you know how to write it out each time. If, using the if and then statement, if two angles add up to a right angle, then they are what?
There.
Complementary. And that's what we write over here. If two angles add up to right angle, then complementary. And it looks like a lot just because what is it, 1, 2, 3, 4, 5, 8, 10, 12, 14, 18, about 22 letters. Wasn't really that much, it was just so packed in there. Somebody tell me what number 3 is going to say then.
That angle 3 and 4 are complementary.
So angle 3 is complementary to angle 4. How do we know that?
Because it makes a right angle.
Two angles add up to right angles, then complementary. Anybody notice anything about all the stuff that we have right now?
All good. Like, not good, but like, good.
Look at what we have. Just like we've been working through with when we do the addition postulate and stuff. You see anything that repeats anywhere?
Yeah.
Complementary does, that's true. What else? Looking at our statements, what else do we see that we've written more than once? Angle 2, anything else?
4.
Angle 4. What do we know about angle 2 and angle 4?
Are congruent.
So we had a theorem that said if these two angles are congruent and they're complementary to these two angles, what do we know about these two angles?
1 and 3 are congruent.
What were we trying to prove?
That 1 and 3 are congruent.
We just got done writing that theorem a minute ago. Remember, the shortened form that I gave you in your notes said angles complementary, actually we wrote the supplementary brother of this. Angles complementary to two congruent angles are what to each other? So these two angles are complementary to these two angles that we know are equal to each other. So what has to be true about these two angles?
They have to be congruent.
They have to be congruent or equal.
And
Was that shorter, Brandon?
we did it.
Yes, we had.
We had like 6 or 7 steps, didn't we? I know you don't care, you don't ever want to shorten anything up, you always want to do it the long, harder way, right? Other questions? How many points would this be worth on a test?
8.
8 points. Should anybody miss these 2 points?
No.
So you got 8 points. There's 2 there. Should everybody get this last statement here?
Yes.
Yes.
How come?
Because it gives it to you.
Now, I don't like saying it gives it to you, but it's the prove statement. And you know that has to come very last thing, right? So how many points do you have now?
3.
3 out of 8? Maybe you don't have any idea what complementary means. I hope not, since we've talked at it till Ebersole's about ready to die because of saying it all the time. Alright? Maybe you don't know any of the rest of them. So you miss all of these. You still got 3 out of 8 points. Not quite 50%. Whole lot better than what percentage though?
0.
0. If you haven't done it yet, come up here. You're going to grab the notes are right here. And then you're going to grab the review packet from that pile there. Give me your calculator.
It takes triple H. I am at like 4. I haven't had it. I told you.
I thought you said you had it here.
I thought I
Oh, Brandon, look.
That's not gonna use them.
Oh, yeah, the packets. As you're going up there and getting that, the 3-6 packet. Turn it, make sure your names are on them. Turn them in on the desk behind Brandon.
Hey, you're not listening. Where? Right there? Right over.
Follow your friends. Follow your friends.
Not be used. No,
So.
no.
Right here,
No, behind Brad.
Just wanna get everything down, can't give you a little-
No, behind Brad is here.
Oh, right
That's why I
there.
left it for you.
Nice, we got the right number before.
Okay.
Brandon, is it at your house?
Yeah.
College payments.
I give you batteries for it, you're not gonna take the batteries and use it for something else stupid, are you? I have no idea.
Is that your car?
Your trucks and it won't start.
Don't take this side fabric.
Jump start with double A's.
That really worries me that he might be driving at some point and he even acknowledged that his truck didn't take that size battery. That, isn't that something you just let go? You don't even say anything back to that.
Hey, Brandon, learn from experience.
On this review, again, the quicker we get through this, the better off for Aaron, because then we get more problems done on the review that'll help him study, and you get more done out of all those that you're supposed to do, right? And we'll talk about that here in a few minutes. Inductive reasoning. Patterns. That's all you gotta remember, patterns. Being able to do patterns. Alright? Make sure you can do that. There's a lot of problems. I'm gonna go through this real quick, because on the review packet, we see stuff with patterns in it, then we're gonna do a problem there that I ain't gotta be more helpful than me sitting up here explaining a whole bunch. Deductive reasoning. Using rules and facts. So inductive is when you see patterns and you decide something or you conclude something. Deductive is when you use rules and facts, like in the 2-column proofs and all that stuff that we've been doing. It's underneath it. There you go. You're up, Chase.
I was just staring at the lights.
Wake up, Dallas.
No, it's weird. He almost had his head down once I was going to yell at him, but then he sat up right away.
Hey,
Change the seats.
you should switch classes with this point to see if it's harder.
Next, I spelled this wrong, but just fit it in there. Conjecture. A conjecture is just a statement. With conjectures, we did the truth value. You just tell whether something is true or false. If they ask you to give a counterexample, if I give you a statement and I say, all numbers are even.
One.
That's all you say. To give a counterexample, you give a specific example, not an explanation, just a specific example. So that's all a counterexample is. An example that shows that the statement is not always true. Don't explain it, just give that specific example. That's a counterexample. If I say something like, Brandon is an idiot, he's going to be able to show me a counterexample come Monday
I don't know.
with his test score.
You better.
Maybe more of a conjecture.
Right, that's my conjecture, but then to prove that that's wrong, his counterexample is going to be, see Ebersole, he's going to show me his test score.
But what if you're right?
I wouldn't be right, because he's going to show me.
Yeah. Yeah. You're gonna create a paper that he's gonna bring back to you and be like, look at this. Like I told you, Ebersole. I could bring up that eye.
Next, be able to find and explain patterns. Nothing to write down on that part, but again, I'm not going to do a whole bunch of patterns up here and stuff. If we want to do that, if you pick out patterns on the review packet when we go to do them, then that's what we'll do. A negation, remember a negation means not. The symbol for negation is this. So if I write this, what's that say?
Okay.
Not cat,
Not cat.
whatever it means, all right? Not cat. A lot of times, when we were doing these problems, they'd have something like not P or not Q or not R, and you had to stick the statements in there and figure out if it was true or false and everything else. Couple of things to write down with the next part here, compound statements. Compound statements are two statements hooked together by and or. How you going to remember which symbol this is? It looks like an A.
With an
All right, looks like an A, so that stands for and. This one stands for or. Couple of things to write down with this. For a conjunction, how is a conjunction going to be true?
both sides are true.
Both parts must be true. For a conjunction to be true,
Is there a reason you're not writing this down? Oh, I wrote everything.
both parts must be true.
You just wrote that on there.
How about a disjunction with the word or?
Oh, only one side needs to be true.
So disjunction, right? Only one part needs to be true. For the whole thing to be true, only one part needs to be true. Everybody handle all that?
Yeah.
Somebody read this to me.
Looks like A.
Looks like A.
Let me write. Let me take my statement a little while ago back. Yeah, I don't even feel like it.
Exactly.
Fill in what you need to fill in on this one. This one's sort of important.
Sort of.
Guarantee that there'll be a problem on there where you have to write converse, inverse, contrapositive, and you have to write something as a conditional statement. And usually when those are on there, count a few extra points because there's so much to do. Nothing really hard about it, just more to write. Just like the 2-column proofs when we get to those. A little more to write, so worth some extra points rather than like just a multiple choice question.
Those are my favorite.
That'd be funny if you were ripping from my binder, just ripping pages off of your hair.
What's another name for a conditional statement? If and then statement. You're gonna have the if part, the then part. The if part's called the hypothesis, the then part's called the conclusion. Make sure you know those two things. When we go to write the converse, inverse, or contrapositive, what's the converse do to a statement?
Switches them.
Just switches the hypothesis and the conclusion. Inverse does what? Negates them. Please make sure you got to go back to the original. Don't negate the converse. That is something completely different. Always go back to the original. What's the contrapositive do?
Both of them.
Does both negates and switches. So if I wrote this, if right angle, then 90 degrees. That's our statement. This part's called the what?
The hypothesis.
Hypothesis. This part's called the conclusion. Is that a true or false statement? That's true. You're going to have to tell on the test whether they're true or false. The converse. What would the converse say?
If 90 degrees, then it's right.
If 90 degrees, then right angle. Is that a true or false statement? That's true also, isn't it? If the original statement and the converse are true, then it's said to be biconditional. And that means I could write this right angle. It's a right angle if and only if it's 90 degrees. And it's got to be true both ways. Remember, this means implies one way, so if I put something like that tells us A implies B.
But B doesn't.
That doesn't mean that B implies A, right? But if I do this,
Yes, no.
then it works both ways. All right? Inverse. What would the inverse say?
If not a right angle, then it's not 90 degrees.
Please make sure you realize she went back to the original statement. If not right angle, then not, sorry, this is pretty ugly, 90 degrees. What would the contrapositive say? And I'm not even going to write it down because I'm running out of
Not
space.
90 degrees, then not right angle.
So contrapositive switches and negates them. So it's going to say if not 90 degrees, then not a right angle. How about the inverse? Was it true? I never did say it.
They're all true.
They're all true, weren't they? So be able to do that, switch the sentences up, rewrite them. Sometimes that's a little hard. You got to make sure that your sentence makes sense. Law of detachment and law of syllogism.
Where's that? Oh, I can read this last one. I thought it
These two laws hard. Landon thinks they're hard. Just remember with the law of detachment, what's detachment mean?
If you take out,
You're taking it apart. So if I had this, if P is the what in this sentence? Hypothesis. Then R is the conclusion. If you have a sentence like this, they're telling you if P then R, and they're telling you it's true. And then they say P, the hypothesis, all by itself is true. What do we know about the conclusion all by itself? It's got to be true. So the conclusion that we can draw is R has to be true all by itself. So if I wrote something like if dog then bow, and then I said dog is true, what can you tell me?
Then bow has to be.
Then bow all by itself has to be true. I'm sorry, I put the instead of then. So bow all by itself, just taking them apart. But it has to be the hypothesis part. If I come down here and I say, for law of syllogism, if I say if dog, then bow, and then I say if bow, then rain, none of it makes any sense. That doesn't matter. What matters is, for the law of syllogism to work, what has to be true about this conclusion right here in the first statement? It's got to be the same as the hypothesis in the second statement. And if that's the case, then you can take this hypothesis and this conclusion and put them together, and we know that that has to be a true statement. So if dog, then rain. But that's the only way it works, if these two are the same as each other. A little bit to write on this one, just tells you some things to make sure you know. Got to know what midpoints are, segment addition. Got to know what vertical angles are, supplementary angles, complementary angles. Something like segment addition here. If I see a picture and it looks like this, I can probably guess I'm using segment addition. What do you know about vertical angles? They're always congruent to each other, always the same. With vertical angles, you might want to draw a picture in there. Vertical angles, got two lines that intersect, angle 1 here, angle 2 there. Those are vertical angles, just to make sure that you can pick out vertical angles in a picture. What do you know about a linear pair? Together they make a line. What else? They're always going to be what to each other? They're always going to be supplementary. They're always going to add up to 180. What do you know about supplementary angles? They add up to 180. What do you know about complementary angles? They add up to 90. What's collinear mean?
They share it.
They're on the same line. What's midpoint mean? This here is probably important. What's midpoint? So what's it do to the segment? Splits it into two congruent segments. What's that upside down T mean? Perpendicular. As soon as you see that upside down T, you should think of perpendicular. As soon as you hear the word perpendicular, what should you think of? Right angles. As soon as you hear right angles, what should you think of?
90 degrees.
90 degrees. And if you're thinking 90 degrees, that might lead us back to what other word? Complementary. All those things go together, and you got to know as soon as you see one, you should be thinking of the other. Now let's all stick your finger in there, man. Come on now, how old are you? I'm still good. That's why Dallas is
Who doesn't?
We know Dallas is smarter than you.
I'll shut my finger down.
Isn't that right, Dallas?
What was he doing?
You're smarter than he is, aren't you?
Everyone's smarter than
A lot
you.
of people are.
Yeah.
I know what kind of batteries my truck takes.
So they're gonna, this is, that's gonna be homework.
I told my truck with battery conversions. Yeah, it actually works too. You'd be great.
Move it out of the way.
Next one, the last thing here, fill in what you need to fill in. With the algebra proofs, you gotta remember all those properties. Please remember with those properties, some of them you gotta put of equality on the end, right? If you do something to both sides of the equal sign. So of equality. With the two column proofs that have segments in it. And I put these on there so that John W. over here gets to one of the two column proofs on the test and he can't remember anything. What would be a good thing if it's dealing with segments? What would be a good thing to put in as a reason? Segment addition postulate. Maybe guess, throw it in there. Might be right. Another good thing to throw in there might be definition of congruency. When do we use that?
When something, no.
That's reflexive property. When do we use definition of congruency?
We have
To
flip
change
it.
from
Switch
algebraic form to the.
Algebra to geometry form or geometry form to algebra form.
Yeah.
Is this just for segments?
No.
No, that would also work down here for angles. We're dealing with angles, and I should have put another one on here. I'll put another one on here. You should look for angle bisectors. If they tell you the angle's being bisected, what's happening to the angle?
It's split into
Two congruent angles, right? We should look for maybe supplementary. What's it mean to be supplementary?
180 degrees.
Add up to 180, two angles add up to 180. What's complementary mean?
Two angles out to 90.
Add up to 90, maybe look for angle addition postulate. Remember that's something like this. We know that angle 1 plus angle 2 here has to equal that whole angle. We just got done doing a few of those problems.
John W.
What's the other one on here that I should put on here that you should be able to see in a picture right away that I don't know why I forgot it? Vertical
Given.
angles are congruent. Should you be able to look at a picture and see that you have vertical angles in there?
Yeah.
Yeah. So if you see a picture, it looks like this with two lines intersecting, and we're dealing with these angles, you might want to make a guess and say, hey, I'm probably going to say something about vertical angles in there.
No.
As some of the people are finishing writing down, get out the packet. We got about 20 minutes. Start looking through it, picking problems, and I'll start working problems on the board. Make sure these notes get into your binder where they belong. Number 2. Does everybody have all this? Yes, no, maybe?
Yeah.
On the packet, number 2. Be ready to pick another one after this. Let P be, you are a senior. So the statement P is, you are a senior. You are a senior. Q is, you are in high school. Write a conditional statement. What's another name for a conditional statement? If and then. So we're going to write an if and then statement. So I'll give you the first word. If what?
You are high, or if you were a senior.
If you are a senior.
You were in high school. And you were in high school.
The next word is then, right?
Yeah.
You are in high school. True or false?
True.
Is that one of the answers down there?
Yeah.
Which one?
C. Wait. Oh yeah. C.
Which one is it?
C.
C? Okay.
I don't know.
Find me another one.
I see.
99.
what did you say? 99. Oh no, not the fruits.
What?
Those take forever. Okay, then not 99.
Too late.
No, not 99. Number 9.
Oh my.
Yeah, that's what he said. He said 9. I said 9.
Sir, when is this due?
Let's do Monday.
10 minutes.
What?
No, I'm just kidding. I'll tell you here in a little while. Okay. Number 9.
Why do you keep doing that?
My pen shut off when it went to the blank screen. So I have to turn back on. Number 9.
9.
This time it says, let P be you are a pitcher, and Q is you are on a baseball team. And it says write the contrapositive and decide whether it's true or false. So first, if, let's just write just like we did on this one, let's just write the if and then statement. If what?
If
you are a pitcher,
You are a pitcher.
then you are on a baseball team.
You are a pitcher. Then, that's a comma. Then, you are on baseball team. This part's called the what?
Hypothesis.
Hypothesis. This part's called the conclusion. What's the contrapositive do to a statement?
Switches and negates.
Switches and negates. So we're going to switch these two and negate both of them. So what's it going to say?
If you are not on the baseball team, then you are not a pitcher.
You are not on baseball team,
So that would be A.
then you are not a pitcher. True or false?
True.
True, everybody agree with that?
Well, it depends. You could be on a softball team.
That's probably true, it could be.
Yeah, you can still be a pitcher.
So the answer is A. We're going with A. Hoping that Chase doesn't grow his hair out and go on the softball team. Next question. Come on, you guys are acting dead here. I thought we'd get like 30 of these done. We got 2 done in like
13.
5 minutes.
12.
13.
That's it.
13. Says use H to represent the hypothesis, C to represent the conclusion, then rewrite the conditional statement in if and then form. Says all 170-degree angles are obtuse angles. I'm going to give you a little help. There, if. What are we going to say? If what?
If an angle is 170.
If angle is 170 degrees, then
Then it is
obtuse angle. I'm not sure what all they ask you to do. Oh, they want you to tell the hypothesis and the conclusion, didn't they? This is the what? Hypothesis. This is the, is that where the answer's down there? A, everybody agrees that it's A?
Yeah.
Next question.
31.
31. Ray AB divides angle CAD into 2 angles. So ray AB is an angle bisector of angle CAD. So they're telling you that that's true. I'm trying to read it here while we go through it. We'll find the counterexample to disprove the conjunction. So we're trying to find a counterexample that disproves it. So let's see. Let me draw this. Ray, what is it? Ray AB? Is that what it is?
Yeah.
So we got something that looks like this, and this is angle CAD. Is that right? Mine looks like it does split it up, doesn't it? Equally. So look at the first one. Measure of angle CAB is 70 degrees. Measure of angle DAB. DAB is how much?
20.
20. Did this bisect the angle?
I know, Miss Roxanne.
So would that be a counterexample? Yeah. Let's look at B. Angle CAB is 20. Angle DAB is 20. If they're both 20, did this bisect it?
Yep.
So we don't want that one because we want a counterexample. C says angle CAB is 20 and the whole thing is 40. If that's the case, if this is 20 and the whole thing's 40, how much is this one?
20.
Did it bisect it?
Yep.
So that wouldn't be a counterexample either, would it? Angle DAB is 60, so this angle's 60. The whole thing is 120. Well, if this is 60, the whole thing's 120, how much is this one?
60.
60. Did it bisect it? Yeah. What's the only one that shows the counterexample? A. Next question. Again, what's a counterexample?
Anything proof conductor.
Shows it's false, right? Specific example shows it's false. Next question. 33. Which statements, if any, about the diagram are true? So 33. Is all right if I don't write this one down up there? You're looking at the picture there, right? Angle PQS and angle SQT are supplementary. True or false?
True.
That's true. So one of our answers we know is going to be what? A. It's number 33. We know one of the answers is A. B. Lost my place here. PQT is a straight angle. Is that true? PQT is a straight angle? Don't, and again, that's one of the things we said earlier in the year. If it looks like a straight angle, what do we know about it? It is a straight angle. We're allowed to assume that, right? So B will work also. C says none of these. So that's false, and D says both A and B. So actually the only real one that we actually probably needed was what?
D.
D. If you put all three in there, I probably won't throw a big fit.
85.
Next, 85. That's because she's actually looking through it and saying, hey, these are the ones that I'm not sure about, I want to see. That's what I took the rest of it. 85 says, write as an if and then statement. A parallelogram is a quadrilateral with two pairs of parallel sides. So we want to write this as an if and then statement. I'll help you out. That's your first word. Switch it around. If it's a
If it's a quadrilateral with two pairs of parallel sides, it's a parallelogram.
you switch it around too much.
If the shape has two pairs of parallel sides.
Switch it around too much. If a quadrilateral is a parallelogram, so if quad is a parallelogram, and I'll help you out again, then what do we know?
It has two pairs of parallel sides.
It has two pairs of parallel sides. This part's called the what?
The hypothesis.
Hypothesis. This part's called the
Conclusion.
conclusion. You didn't need to tell the hypothesis and conclusion.
84.
Just need to write the sentence. Number 84?
Yeah.
Yeah.
84 says, how many line segments will be needed to create step 4 in the sequence? So this is a pattern, right? So, let's see here. step 1 to step 2. What are they doing?
Just adding 2 on each.
They're adding 2 to each line segment.
So each end has 2 more added to it to get to the next step, right?
Yes.
So that's step 2, and then step 3, we would add 2 to here, 2 to here, 2 to here, 2 to here, that's step 3. So step 4, how many are we gonna add to here?
2,
Here,
2,
here,
2, 2, 2, 2, 2, 2.
so 2 to each one of those. Let's see, let me read the question again, make sure that I don't get it wrong. How many line segments will be needed to create step 4?
60.
So 2, 4, 6, 8, 10, 2, 4, 6, 8, 10, 12, 14, 16. Now, be careful, because I'm not sure here. Is our answer 16?
I think you should add them all up.
We should add them all up. That should be the way it is. Make sure you're watching, because this is what we're going to do on the test. 16 is just to finish it out, right?
How many, that's how much segments in total?
How many did we, it asked for the total, so we need to go back, how many segments were there in step 3?
1, 2, 3, 4, 5, 6, 7, 8, 14.
14? Everybody agree with that?
Sure. Yeah.
Is it 14?
Yeah.
So how would we get the total?
Add it to 16.
So how many segments to create that final thing? 30.
29.
29?
29 plus 1.
Let's see what is problem 29. Problem 29. Directions say name the property that the statement illustrates. They tell us segment MN is congruent to segment XY and segment XY is congruent to segment RS. Then we can decide that MN is congruent to RS. What property did I tell you to use on this? That's not one of the answers.
Law still good. Substitute.
Substitution. Alright? It looks like the law of syllogism, sort of, doesn't it?
Or translated.
So-
I was on the right track.
So what is it, Hayden?
Transitive.
Transitive property. Remember, transitive property and substitution are the same thing, right? But we use substitution because it always works. Transitive property works if it's in the right pattern.
Substitution covers more ground.
And that right pattern is these two have to be the same. Are they the same?
Yes.
Yes.
Yeah, so which property?
Transitive.
Transitive property, what letter is that?
A.
A.
Did we do 25 too?
25. 25 says this, CD is congruent to CD. What tells you that? Reflexive property. Reflexive property, is that one of the answers?
Yeah.
Which one?
B.
B.
Anything equals itself.
Anything equals itself, so the answer to this one is B. Next question. 26 is also reflexive, Brandon said, so that's an easy one to do real quick, isn't it?
A.
32, since we're on that page.
32?
Yeah.
They give you a conjecture here. It says, find a counterexample. The product of a positive integer and a negative integer is always less than either number. So 32. We want the product. That means we're multiplying. A positive number, positive integer, and a negative integer. That just means it's got to be a whole number, right? No decimals or fractions.
Yeah.
You don't do that.
Give me a positive integer.
4.
4. Give me a negative integer.
Negative 4.
4 times negative 4 is negative 16. So they wanted this to be less than either one of these two, is it? Yeah, so that is. So is that a counterexample? No, that doesn't help us, does it? So we got to find something where
What?
it's a counterexample. So 1 is our positive number. What's our negative number? Negative what? 3. What's 1 times negative 3?
Negative 3.
Is 1 times negative 3, that gives us 3. Is this number less than either one of these two? No, it's the same as. So that's a good counterexample. Is that one that they have down there?
Yeah.
D? Are there other counterexamples? Yeah, there's a whole bunch of them. Next question. 17. I like problem 30 there. 17. State the law of logic that illustrates, or that is illustrated. We only had 2 laws, right? What were the 2 laws? Syllogism and detachment. So 17 says if you get an A on your math test, then you can choose where to go to dinner. If you choose where to go to dinner, then you can go to your favorite restaurant. First of all, does that fit one of the 2 laws? Yeah. Are the 2 things in the middle the same?
Yeah.
Yeah. So we can say, just put the first hypothesis with the final conclusion. If you get an A on your math test, then you can go to your favorite restaurant. What law is that? Syllogism. So 17 is A, law of syllogism. Law of syllogism.
We have enough time to do 30.
Yeah. Said 30?
Yeah.
Problem 30. Looks like this. I'm not going to draw it real quick. Somebody help me out because I can't read none of that.
4x plus 34. And then across from it is 54.
What do we know about these 2 angles?
They're equal.
They're equal to each other. So what equation can I set up?
4x plus 34 equals 54.
What if this 54 had been up here instead?
We just put it equal to 180.
They add them up to equal 180. All right, 4x equals 20. X equals how much? What is it? 5. X equals 5. What did they ask us to find?
What x
Find
equals?
X. So which answer is that?
C.
C. On this, do not have to complete all of this, all right? I'm not going to give you a number to complete, because as soon as I give a number to complete, what's going to happen?
Oh.
That's where you're going to stop at, right? No, you ain't going to do no more than that. I can tell in Dallas's eyes, if I said, do 5, he'd do 5 and never have to do another. You don't have to complete it all. When I collect it next time, it doesn't all have to be completed. What I will do is I have a number in my head, how many I want you to complete.
If you don't reach that, you don't.
If you don't reach that, you don't get full credit. Now, it's not, my number is not something stupid like 99 or 98.
I said 60.
I'd say somewhere a little higher than 20 probably.
30, 35.
Somewhere around that area might be a good guess. If you do more than what's in my head, I'll probably count it as extra credit or bonus. And I may add it right to your test score this time.
I say do all.